Now, if you've ever driven a car, if you have a driver's license, then you know that it is a lot easier driving in a forward gear than a reverse gear. It's kind of hard to drive in reverse at 55 miles per hour. Maybe you might blow up your engine if you drive that fast, so maybe 20 miles per hour is better. And if you have an ionic formula and you go to a name, it's a little bit harder sometimes than going from a name to a formula. So let's go ahead and try and give a name to an ionic formula. So for instance, if we had something, golly gosh, like mg, s. Oh no, that's the one we just did, right? So how about if we had something like K2O? Okay, I think that's pretty reasonable. We can turn that into a name, and the way we have to turn it into a name is first off recognize it's ionic. So how do we know it's ionic? Well, potassium is a metal and oxygen's a non-metal. They're on opposing sides of the periodic table. From where potassium is on the periodic table, we know that its charge is 1 positive. How do we know that? Potassium is all the way down here in group 1A, and we know all these guys make a 1 positive ion. And if we go all the way to the other side of the table, 7A and 6A and so on, and 8A's are noble gases, so 6A is where oxygen is, it's somewhere at the top. I haven't drawn that very well. And these all have a charge of 2 minus. Okay, and how do you figure that out? Well, the noble gases are 0, 1 minus, 2 minus, so oxygen has a 2 minus charge, and that makes sense, the formula. So the formula says K2O, okay, that's not a mountain range. Why is there a 2 next to the K? Well, we need 2 Ks, or 2 potassiums, to cancel out the charge on 1 oxygen. So that kind of helps me make sure things are okay. So if the formula was crazy, right, then what I did underneath, the charges wouldn't cancel out, the golden rule would be disobeyed. So what comes next? So what comes next is we name the cation, and then we name the anion. Potassium, we could write it potassium 1 if it varied, but because it doesn't vary, potassium is just fine. And then O is oxygen. And the thing about oxygen, right, is we switch the ending for IDE. So potassium oxide, with a space in between, would be the name of that compound. And incidentally, we add things like potassium oxide to sand. Sorry, that word didn't come out. And it helps the sand melt at a lower temperature. And when we convert it into glass, it's extremely helpful if it melts at a much lower temperature than normal. So potassium oxide is pretty awesome stuff. Now, you may be wondering, is it a proper or an improper name? So it is not capitalized unless it's the start of a sentence. It is not like Bob or John or Mary or Amy, where you have to capitalize those names. It is lowercase unless, of course, it starts a sentence. So that is the end of K2O. So let's go to another formula and try and give it a name. And let's pick something tricky. So, for instance, we could pick something like Cu2... S. How about something like that? So Cu2S. So again, we've got a metal and a non-metal. It's a transition metal, but it's still a metal. Sulfur's a non-metal, so we definitely know it's ionic. Cu, unfortunately, is one of those variable charged ions. So we really don't know what it is. I mean, we know, if you remember before, it can be always 1 or 2 positive, but for now, we'll just go ahead and say it is question mark. What about the S? Well, the S is sulfur, and sulfur is at group 6A, so it's not the top member. I was about to say it's at the top of 6A, but it's the second one, and these guys are all 2 negative, right? So 7A would be things like fluorine and chlorine. These are 1 negative, and 8A, these are things like helium, neon, argon, so they have no charge at all, so I'll just write a 0 there. So it is 2 minus. And here's the thing, the golden rule says that the charges have to cancel. So that means the 2 negatives coming from the sulfur have to be canceled out by 2 positives coming from the copper. And the easiest way to imagine this is that instead of writing a question mark there, right, we can say each copper has to be positive 1, so in order for the charges to cancel out. So we've got 2 coppers, right, each one with a positive 1 charge, and 1 sulfur with a 2 minus charge. And then we name this. And because the charge can vary, when we name copper, I don't know why I capitalized the C, maybe it's at the start of a sentence, we name the charge afterwards in Roman numerals, so it would be copper 1, and then sulfur, we just replace the ending with IDE, so it would be copper 1 sulfide. Now, some people would want to write copper 2 sulfide, and there is a compound called copper 2 sulfide, but it ain't this one. So the 1 is the charge on each individual copper. So although there are 2 charges in total, and although there are 2 coppers in total, the number there refers to the charge on each individual copper ion. So copper 1 sulfide. And I wonder if you could remember what the old name for copper 1 is. So pause the video, maybe look back through your notes or look back through your brain, and what's copper 1 also called? Okay, copper 1 is called, well, copper is cuprum, and copper 1, well, you can't get much lower than 1 actually and still be an ion, at least a cation, I suppose. So it was cuprous, so we use us for the lower and ic for the higher charge. So cuprous sulfide would be the full name, the older name of this compound, I suppose. So copper 1 sulfide or cuprous sulfide, either one would work. Some people ask, they're like, if you had to name it on an exam, which one would you give? And I would say give whichever one you are most confident about getting right. Some people say, can I give both? And I say, you can if you really want to, but if you name one of them incorrectly, even though you get the other one wrong, or other one right, I will take off points. So best to only give one, and only give the one that you're absolutely sure about. I sometimes will ask for the stock name, which is this way of doing it, versus the older name, but if I don't ask, you can do it whichever way, and I think the stock method is much, much easier, so I would only go this way if you know you're in the health-oriented fields and you just want extra practice at this stuff. Okay, let's try another one. Okay, are you ready for a difficult one here? I'm going to write Fe2S3. I wonder if you could name that one. You can pause the video now and go ahead and name it both the old and the new way if you want to, and we can compare notes, or you can just follow along in a minute. Okay, I lied. More like 5 seconds. So how would you name this? Well, first off, you'd have to be sure it was ionic, and iron's a metal, sulfur's a non-metal, so we're definitely sure there. We have 2 irons. Kind of a tongue twister. We got 2 iron ions. So we got 3 sulfur ions. Based on where sulfur is on the periodic table, it has a charge of 2 minus. It's 2 away from the noble gases. So always bring up your periodic table. Let's have a quick look. So here's our periodic table. So sulfur, right there. So group 6A. So 0, 1 minus, 2 minus. Not in class. I kind of just run over to the periodic table and I point. And whichever poor soul is right next to the periodic table has me pointing right next to them for the whole semester long. So I think it's a great habit to get into. So print off a periodic table and keep pointing and scribbling. There's iron, right? So it's in the transition metal block, so it can have a variable charge. But sulfur, right, is main group, non-metal, all the way up here, right? So it's always going to be 2 minus. And yes, okay, so how do we name this? Well, the sulfur part's pretty easy. We can name this first for fun. So sulfur becomes sulfide. We just switch the ending to IDE. Now the iron, though, has a name, and because it can vary the charge, we have to give it a name depending on the charge it has. How do we figure it out? Well, the 3 sulfurs have an overall charge of 6 minus. The golden rule, right? So do unto others as you would want them to do unto you. Or in ionic compounds, the golden rule is the charges have to cancel. So 6 minuses have to be canceled out by 6 pluses. And if there's 2 irons, that means each one presumably has to be 3 plus. So the iron is, would that be iron 6 or iron 3? Yeah, iron 3. So remember, we give the charge of each individual ion. So each iron ion, that's a tongue twister, is 3 positive, so we call it iron 3 sulfide. And the older name for that, iron 3, is the higher charge. So you want to try ahead and come with that. Pause the video and have a go. Okay, if you've unpaused, ferrum is iron. So fer, we would start with, it's the higher one, so it's ferric. And sulfide, so in the older name, right, we don't change the anion part of it, just the cation. So ferric sulfide. And sulfide is not very good for you. It's pretty disgusting, actually. Iron 3 is also not very good to you, so good for you. Blech. So I wouldn't recommend eating this compound, that's for sure. Shouldn't eat anything, actually, but definitely don't want to eat iron 3 sulfide. Yuck.